particular project, this area right here is Interstate 5 going down through this county. So you can see that, of course, as it works out, Murphy always works on that. Your simulcast overlap distortion is right down the major intersection. You look right there, there's a name that says courthouse. So right where the courthouse is, all that is right where all the simulcast overlap distortion is. So obviously, this would not have been a good design. As a result, this site, this particular one, needed at least 2 more sites to resolve some of these. Now, some of this area wasn't such a concern. This is out of the pucker brush. This is all mountains. So nobody really cared too much about that, but this was a bad deal. Now, so this would have been bad enough. Now, if you take the same design and you put this in narrowband, here's what happens. Now, all of a sudden, look at these huge swaths of area now that are going to have simulcast overlap distortion. So not only did we have just down I-5, but now this whole area, which is where a lot of the population and the industry was in this county, is now no longer. I mean, the signal strengths are really good there. They're in this green area, so it's plenty of signal, but the audio is going to be distorted. And the same problem out over here. Again, this is out the pucker brush. Nobody cares too much about this, but again, in this area here is farmland and a fair amount of tourist traffic. But certainly this is all down the Interstate 5 here. Well, this isn't the green here, but this is all down Interstate 5. Lots of traffic accidents and things like that. So in this particular case, putting in a wideband system that was marginal and then switching it to narrowband later on, would have created a significant amount of trouble. So you cannot rely on signal strength for 2 things. Number 1, you can't rely on it when you're doing coverage predictions. You have to add simulcast delay distortion. And number 2, you can't, if you're going to do an acceptance test and you're going to drive around with a spectrum analyzer or some sort of signal level meter to verify that you've got the right coverage, you can't do it with just signal strength because you have to do a delivered audio quality test when you're doing simulcast. It's the only way to, I guess it's good news for you if you're the vendor, right? You only do a signal level test. Hey, it works great, it passes. But you're going to have a very unhappy customer when they actually get out there and start using the system. And if you're a customer, you're buying a system, you want to make sure that you don't accept the system without doing a delivered audio quality test, wideband or narrowband, or digital. Okay, so let's talk a little bit more again about narrowband simulcast. Finding an overlap control is more critical. Again, the system looks like, starting to look like AM, less like FM. A higher degree of RF engineering is required because those overlap areas are quite a bit bigger. Antenna power level adjustments may need to be made after the installation, which is true for any simulcast, but higher likelihood for narrowband because your overlap areas are getting larger. And this, all of the same basic adjustments apply in test equipment and attention to detail. It's just it's worse for narrowband. And this actually is true even if you're not doing narrowband simulcast. If you're just putting in a narrowband system, getting your levels correct is much more critical because now your average deviation is 1.5 kilohertz or so, and your CTCS deviations are down around 200 or 300 hertz. And there's a lot of equipment that doesn't decode CTCSS very well at some of those lower levels. So it's really, sometimes you make the conversion and just everything goes great. Other times you have all kinds of problems. So you have to be aware of it. The other thing is you have to remember that some of your performance problems when you convert to narrowband simulcast may not be related to simulcast, but may be related to the fact that you have just converted to narrowband. So, maybe you convert to, say you have a wideband simulcast system now, you convert it to narrowband, and now you start having a lot of problems. May not be the simulcast system that's causing the problems. It could be that that radio you're using, that brand or model, just doesn't work very well for CTCSS decoding or whatever else. Maybe the audio is noisy. That's just simply related to the fact that you're moving to narrowband. So be sure you check the narrowband before you run off and adjust your simulcast system. Make sure that you verify that the radio is working, really works okay in a conventional non-simulcast environment as well. Because we've seen quite a variation between models when you go to narrowband. Multipath fading and the narrow IF response, depends again on the model, but as the IF response is narrow on the radios, their ability to handle rapid changes in signal level go down. What ends up happening is you can actually cause the IF filters to ring, and that makes the audio quality and sort of the popping noise you get from that worse. That's going to be less of a problem at VHF, because the nulls usually don't occur quite so fast unless you're driving really quickly, but it can be more of a problem at UHF. Companding should be turned off. Now this is the companding that the manufacturers are using, not the audio processing that I talked about before, which is done to all, I mean, all the audio is treated the same, as opposed to having companding that's actually done inside the radio equipment. And you know, you have to remember that you're just dealing with a lot lower audio levels, and so there's a lot less margin. So we'll make sure that again the levels are set properly. It's harder. There's less margin for error, as I said. It's really getting harder to make the adjustments because you're getting closer and closer to sort of the bottom end of your service monitors and your other equipment. Even if you have new equipment, your adjustments now are starting to get closer to zero. You know, if you're going to set your CTCSS level at 200 or 300 hertz, for example, you know, there's not, depending on your service monitor, sometimes you get some of the bounce down there at the bottom. And as I've taught before, you really need to use a monitor receiver to set those levels, but you know, even trying to rough them in sometimes with a service monitor, and this goes with regular narrowband as well, can be a little bit difficult. The other thing is you might have to upgrade your monitor receiver because the noise levels in the monitor receiver may be higher due to less quieting and make your level adjustments higher. One of the other things, if you look at narrowbanding in general, if you look at the performance specs, a lot of the equipment, what you see is the noise levels go up in the radios. The hum and noise, look at the hum and noise spec for the transmitters and the receivers. A lot of times you'll see that it's 10 dB higher in a narrowband radio, sometimes even higher. So that's another effect that can reduce the overall, even in a non-simulcast environment, but it makes it worse in the simulcast. And again, the simulcast artifacts, the delay, distortion, that kind of stuff, may be more noticeable due to the lower audio recovery and your lower modulation index. So, conclusion, narrowband simulcast can be done. It requires more care. Back to the same thing, simulcast is a spectrally efficient technology. I think for a lot of places, more and more people are going to have to sort of be forced into simulcast because you just can't get the channels in a lot of areas. And this is being pushed out even into a lot of the rural areas. If you want to add better coverage, you just can't throw another repeater on a mountaintop on another frequency because it just aren't available. Narrowband by itself will result in some system degradation, so you need to take that into account, not only for your simulcast systems if you're converting them to narrowband, but if you're engineering a new system or if you have just a conventional system. And then make sure you allow for some adjustment time after implementation, so that after it gets all done, if you're bidding one of these jobs, but make sure that you allow some time so you can go in and tweak power levels, antenna patterns, things like that. We'll allow you to do some final adjustments. I get calls from dealers occasionally that talk about, well, they've got the system in, they're having some trouble, so I'll talk to them, maybe rerun their coverage predictions and say, well, you got to replace this, you got to change the antenna on this water tank from, omnidirectional to some sort of a pattern antenna, and that should resolve your problem. And they go, well, I can't do that because, the money in the project's all gone. I don't have any more budget left to do this. And well, yeah, I can't change the laws of physics. So, if you're that's what needs to be done. That's kind of what needs to be done. So.